initiative to say a couple of words here. First, I think there's a couple of things we have to keep in mind. And first, I may be preempting at something Ed's going to say in a minute, but thinking about what does the ACGIH standard say? It talks about millijoules per square centimeter, not microwatts per square centimeter. And that is an important distinction because people move around. They don't stay in the same position. They don't stand directly under the light for 8 hours to get the dose that you would expect based on an irradiance measurement. And that's really, really important. And Ed had a paper a decade or so ago showing that with upper room UV, with actual dose measurements, that people's exposures in the rooms were a small fraction of what the irradiance measurements would give you. And so it's important not to confuse these things. This is much more what we need for monitoring this in terms of UV dose, our dose measurement techniques such as film badges that can integrate the exposure and this is very standard kind of industrial hygiene monitoring where you put personal monitors on people. And we need to think about it that way, not like irradiance. I think that another point we have to think about is where is the added value to using germicidal UV? When we look back at the Wells studies in the elementary schools in Germantown and Swarthmore, they measured equivalent air changes that they were getting from their UV system. And they were in excess of 100 equivalent air changes an hour in those rooms. And that's what it took to control measles. That's what it takes to control super spreading events. And so we need to be thinking about where do you need that? When do you use this? And that then impacts the risk calculations and the risk benefit calculations, because we probably aren't talking about this being used everywhere and in homes, in spite of the fact that there's a paper from Southeast Asia where somebody is suggesting we do that. And we know that there was discussion of that here in the 40s. That's mostly not what we're talking about. And most people are not going to invest that much money to put it into their homes. So coming up with these risk benefit discussions and thinking about the balance between ventilation and UV and where's the sweet spot and where do we use it, that's going to be really important. And finally, one thing that we haven't seen in this discussion yet is filtration and ventilation are not exactly the same thing. And we have seen recently where you don't want to ventilate when you have wildfire smoke, putting the PM levels up to extremely high levels outside, and that you want to be using filtration. And so maybe we need to be thinking carefully about where filtration fits into this and not simply lump it together with ventilation. So with those comments, I'll open to discussion. So we start down front here and work our way around.
Well, first of all, thank you to all the speakers this morning, really sort of getting to the crux of the matter. I did want to maybe re-show the slide that Shelley showed yesterday in the first talk. Is it possible to get that slide up, please?
Oh. So well, when we don't have that slide.
Well, if you recall okay, let me go back a step. So what I was looking for really this morning was measurements of ozone levels in realistic rooms, offices, and so on. Although it's interesting to see these, and from a basic science point of view, important to see these measurements in chambers which are specifically designed to keep the ozone in and not absorb it. That's not actually what we're interested in. We're interested in what are the ozone levels in homes. And I saw two numbers actually at this meeting, Dr. Peng showed some measurements where the ozone level went up from 4 ppb to 8 ppb. And Holger showed some measurements again where the increases were that sort of level, single digits essentially. So that's really what we're working with. So there are then two questions. Is an increase in a single digit ppb ozone level, is that in itself going to be a health consequences? And then what about the secondary particles produced by that? So, okay. So again, remember now we're talking about single digit ppbs. And this is probably the best data we have in terms of the dose response relationship between excess relative risk for respiratory mortality and ozone concentrations. So when we're talking about single digit ppbs, we're on the left of this graph, we're outside this graph. And basically at higher levels, it's clear that ozone is a risk. But when you get down to these levels, there's no evidence at all that there's a risk associated.
But David, that's not really the point. The point is the secondary aerosols.
Coming to that. So built into these studies is the mortality from the secondary particles, because I mean, when you breathe in ozone, you're also going to be breathing in the secondary particles. So it's built into these studies. Now they
no, it's factored out.
They make corrections for PM 2.5s.
Yeah, so this is from models that account for the effect of PM 2.5 separately and factor that out. So this is the effect of ozone alone with PM 2.5 held constant.
Yeah. So again, I'm not sure I agree with Shelley's comment. Read the paper, and you will find that the factors that they had to build in to take out the PM 2.5s were very small indeed. Really didn't have significant consequences. So I would argue that built into this are the secondary particles, and they indeed tried to factor them out, but it didn't make any difference to the overall risk estimates whether they had them in or out.
Well, it would be interesting to get Michael Jarrett to come in and comment on that. I'm sure he would not agree with you on that.
Well, it's pretty explicit in the paper. But again, I would argue that what we know is that the VOCs indoors and outdoors in public places are pretty similar. So the secondary particulate production in outdoors, like here, is going to be pretty similar to the secondary production indoors because the VOCs are pretty similar.
I think we need to move on to some other discussion here. So over there, we have a couple people over there.
I just want to quickly make the point that the chemistry is not the same, right? So even if the VOCs are the same, one thing we showed in our work is that in addition to the ozone, there's OH. And so for the same sort of bang for your buck for the amount of ozone, even if it's only 5 ppb or whatever it's shown, and I believe that number is true for what it's worth, that doesn't necessarily mean that you're going to get the same amount of aerosol. And I think with 222, it's pretty likely that for the same amount of ozone, you're going to get more aerosol because there's this additional oxidant present.
Yeah, I'm not saying that there's no risk. I'm saying that there's no evidence of risk. I mean, have there been measurements at these low levels of ozone and all these secondary products in terms of human health consequences? And I'd say the answer is no.
Go over here.
And I also thank everybody for their excellent talks. Two questions, and I guess the first one might be Victoria, and then the others, and that's what is a relationship between ozone generation and fluence rate and the byproducts linear? Because I know in the Victoria study, it was what, 45 microwatts per square centimeter. You know, if somebody had 10 or 5 microwatts per square centimeter fluence rate in the room, would you have the same linear type relationship or reduction as you go down? And the second part of the question is, you know, I try to think of things in simplistic matters, but based on what I heard today, we really need a simplistic risk model that deals with the algorithm of fluence rate, byproduct generation, and minimum air changes per hour. And I think something like that would take into account some of Jose's concerns and some of the other information presented. Thank you.
Yeah, so as far as your question about the linearity, the ozone should be roughly linear. The OH is 100% not. And the byproduct formation is also 100% not. And so I fully agree with you that additional measurements at different fluence rates are necessary. And I am curious from the folks at USHIO in the room if they have any thoughts on the best way to accurately attenuate those lamps so that we can make those measurements in the lab.
And I would argue just don't always lump ventilation and filtration together. There's a question here. And here.
Thanks for that extensive discussion of ozone. I wanted to push back. It echoes what Don said a little bit about the quick jumping to the conclusion that the answer is to cut back on the fluence rate in the room and the effectiveness of the air disinfection. We have to look for other solutions. And the reason for that is, as Don said, these infections tend to be driven by super spreader events. And if those events are under very poor ventilation, then small increments in ventilation or filtration help dramatically, as Wells Riley would suggest. If, however, they occur under conditions of decent ventilation for comfort, basically you have to double ventilation to reduce risk by half. And if the risk is very high, half isn't good enough. So can you double it again? Can you double it again to get down to smaller and smaller rates? You can't with air movement. So this technology is uniquely suitable for dealing with super spreader events, and we have to figure out a way to make it safe.
Here. And up there.
I have a question about non-photochemical produced ozone from the lamps. There was some data showing that because all of the krypton chloride lamps are based on high voltage dielectric barriers. And the barrier discharge, which is external to the gas, can produce ozone. And some lamps produce more than others, and it may depend on what the power is, but it's non-photochemical ozone. So have any of the measurements or manufacturers considered that?
I will note that in what was displayed in the talk it was one lamp from one manufacturer. The other lamp from that manufacturer wasn't doing it, and none of the others did. So clearly there's a quality control issue here, and maybe one of the manufacturers wants to respond about that.
Okay, can you hear me? Hi, this is Paul Locke. I'm from Johns Hopkins Bloomberg School of Public Health. I'd like to take things in a little bit different direction.
Yeah, so can somebody respond about the arcing issue?
Oh.
Okay.
Yeah, so what I can say is that there's a window in time when we found that the there was occasional electric discharge due to the construction of the lamp. And I'm almost certain that's exactly what happened there, that was just, well, we've totally resolved that. But there was we're all new companies with new technologies. There was a time when we did have occasional electrical discharges that occurred. I could explain exactly where and why and how and all that, but we've resolved that. We've changed the design of that. It doesn't occur anymore. So I would be shocked to find a new lamp with that same variation.
And the UL test methods actually are designed to look at that sort of
Yep.
production.
Yep.
Yes.
So I would like to just point out that there's been a lot of discussion here about TLVs and ACGIH. And from a policy perspective, these are occupational health or occupationally environmentally related standards. These are not standards for indoor air in other buildings, especially homes. In fact, we don't have, EPA does not have authority to regulate indoor air in this country. So when you're doing and thinking about your risk modeling and you're thinking about standards, those standards are not appropriate because they're based on an entirely different set of assumptions, a different population, which I think you alluded to. And it's important to keep that in mind. I'm not here to predict what EPA might get authority to do in the future, but I am really concerned when you start to think about modeling and you are using the ACGIH TLVs to talk about non-occupational environments, because I think you're getting into territory that is very dangerous from a policy perspective.
Thank you. I think on the other side of that, and that's true that these are not developed for the general population and for vulnerable populations. But the fact that they are generally implemented as irradiance, peak irradiance, and to stay below that. And the result is that the dose achieved by people in those environments is usually about 1% of that, means that they are still quite conservative for the general population if used as irradiance standards. Oh. Okay, I thought you were talking about the skin and eye issues, which is what the ACGIH is key to, not to this newer photochemistry issue, where I think the concern in the generally here seems to be that we want to do something about how we use this to drive those implications down much, much lower, and think about how do we use them. As one of the speakers yesterday, Mohammed Subani, said, how do we use them in a smarter way? That's what we're trying to do. Ewan.
Yeah, thank you. I also want to just take the conversation a slightly different way in that, so I liked Holger's idea of a parts per billion per hour per microwatt per centimeter squared, but we can't decouple the ozone generation from the inactivation. They both depend on the light that is in the room. So if you're going to do that for ozone, you have to do it for the inactivation as well. And so then I would say it's probably the people that are in this room have to couple the two of them together to work out in a real, again, Holger, in a realistic room, what inactivation can you actually achieve with these lamps? Can you stop transmission in a super spreader event? Maybe not. We don't know. And then how low can you go with the amount of light that's in that room to still get that end point that you want? So they're intimately interlinked.
Or what other technologies do you need to be employing first before you put in UV? Well, we're at 10:30 and it's time for a break. Thank you for the wonderful talk today and the great